Circuits are used in various areas. So you can analyze, design, simulate certain analog, mixed mode, millimeter wave, RF, power, and digital circuits. And you can use them in several applications such as computation, computer architecture, sensing as sensors, cyber physical, biomedical. So for instance, this chip at the right is a wake-up sensor. And it is used in sensors because sensors have to be ultra low power. So wake-up sensor detects that a sensor is not working, so it cuts the power to the sensor so that sensor doesn't consume power. So in the Internet of Things era, IoT, everything will be sensors. There will be sensors on the cars, autonomous cars like Tesla and so on. There will be sensors on industrial robots. There will be sensors on our clothes. So these sensors will have to basically operate in low power. Also, this is my expertise area, wireless communication transceivers and low power integrated circuits. That's why I explained a little bit in detail. But you can use circuits in VLSI, which is digital circuits, ASIC design. You can use it in high-speed digital communications like optical interfaces, or you can use it in digital signal processing. You can use it in multiprocessor computing. You can use it in microelectronic circuits. So there are a lot of areas, which I will briefly explain in the next slides. Sensors, there are a lot of sensors in, as I mentioned, in the several applications, and MEMS, microelectromechanical systems, are combined with microelectronics to provide these different products. There is Internet of Things. We place different Wi-Fi chips everywhere right now, right? For instance, you can control the heat of a smart house when you are working at office. You can turn on the heater before you come to home through your phone, right? So everything, all the devices will be connecting each other, car-to-car communication, car-to-home communication, person-to-person communication is already happening through our cell phones, right? Not just humans, but also devices will be communicating. So the circuits, microelectronics used in medical electronics. So the doctors can put a chip on the top of the head, and instead of using those bulky devices, and that can send all the signals wirelessly to your doctor without any bulky devices like that in the hospitals. Brain machine interfaces, like, you can think something and you don't even talk about it. It will detect your signals. It will detect your thinking, like alpha, gamma signals, and it will interpret those signals through those circuits and DSP, of course, digital signal processing sites. There will be always a computer power needed. Without talking, you can move things, you can apply things, right? Soldiers don't even talk in the fields, they just think. In the movies you say right, left, fire in the hole, right? So without even talking, but just thinking, soldiers can understand each other. There are sensors, it tells, when somebody thinks right, for instance, there are sensors on the body and they light or they vibrate. So a lot of interesting stuff happening. There is sonogram ultrasounds. You can put these different sensors on the body without going to hospital. With these sensors, doctors will be able to diagnose. The photonics is being a really important area because the speed is important. And when speed is important, photonics comes to effect. Because the laser diodes cannot be replaceable with anything, like in terms of speed. So these laser diodes, photonics, always have electronics behind it. So that's why you can use the microelectronics. Ultrasounds powering tomorrow devices. As you can see here, using MEMS and some other electronics, you can put these chips on the tongue or on the body like a skin. It can even power these devices with your vibrations and live signals. It can turn your movements into energy. So the future is, as you see in these slides, are becoming very connected, very scalable, and it will have a total different perspective compared to the past 10 years, because it's progressing very, very fast with obvious autonomous devices. So as you see here in this person picture, it is imagined that a person will be wearing all those sensors in 10 years to create energy, to communicate with other people, communicate with other devices. So basically hyper connecting everything. There are certain things important in signal processing parts, which you are probably taking a signal class, or maybe you took it last year. So there are bottlenecks like data rates, capacity, power consumption, security, coexistence, and these are signal bottlenecks, which are signal engineers and communication software engineers working on it. So with 5G, which is a totally different technology, also microelectronics is required together with Internet of Things. By 2020, there were 50 billion devices connected this year. And they think that there will be a significant growth in the next 3 years. So there is also industrial side of it. The factories, how will they benefit from this Internet of Things? Through smart power, generating clean energy, smart machines, autonomous tractors, smart communications, smart grids. They build electricity according to your demand of electricity. The instrumentations, smart tests, measurements. So it's been crazy. Tools.